Test review 3, covering module 3 of quadratic functions. Question 1. Graph f of x equaling x squared plus 6x plus 8 and find the solutions. Again, the solutions to a quadratic would be the x-intercepts. So when we graph this, we want to make sure that we can identify where it crosses the x-axis. So there are a couple ways you can do this. You could actually put this into your graphing calculator and use the table feature to come up with your points. But if you don't have a graphing calculator, we can use the formula b divided by 2a, or the opposite of b divided by 2a. And that would tell us the axis of symmetry, which goes right through the vertex. So our b is 6. So if we take the opposite of 6, so that would be a negative 6, divided by 2a, and our a is 1, we would get negative 6 divided by 2, which is negative 3. That means I have the axis of symmetry at negative 3, so I'm going to put my axis of symmetry through here. Next, we need to put that number in for x to find out where on the axis of symmetry is our vertex. So if I put negative 3 in for x, I would get 9 minus 18 plus 8. So 9 minus 18 is a negative 9, and a negative 9 plus 8 is a negative 1. So I would have a point at negative 3 and negative 1. So if that's our vertex, all I need to do is pick a number on each side of the axis of symmetry to find another point that would create my quadratic. So for this one, I will choose, let's just say if I put a 2 in for x. If I put a 2 in for x, or a negative 2, negative 2, that would give us 4 minus 12 plus 8. So 4 minus 12 is negative 8. Negative 8 plus 8 is 0. So that means I have a point at negative 2, 0. And then if that's one step to the right of the axis, I can mirror that one and go one step to the left, and that would be at negative 4. But to verify that, if I put negative 4 in for x, that would give me negative 4 squared would be 16 minus 6 times negative 4. So that gives me my negative 24. And then plus 8. So 16 minus 24 is negative 8. Negative 8 plus 8 gives you 0. So I have everything I need to now draw my parabola. That means the solutions would be x equaling negative 4 and negative 2. Question 2, write an equation that models the function. So depending on what information they give us in the graph, you can write it either as standard form, which is y equals ax squared plus bx plus c. You could put it in vertex form if you know what the vertex is. You could also put it in factored form if you know what the x-intercepts are. Now for this one, I can see that I can identify the vertex, and I also have the zeros. So the easiest way that I'm going to use for this one is I'm going to put this in vertex form, which would be f of x, or y, equaling a times parentheses x minus h squared plus k, where h and k is your vertex. So if the vertex here is negative 1, negative 1, and then I'm going to choose this point 0, 0 for my x and y. So then I can find my a. So if I put a 0 in for x, or for y, equaling, I don't know my a, my x term is 0, minus my h is a negative 1, so a negative 1 squared, and then my k is a negative 1. So to simplify this, 0 minus a negative 1 really means 0 plus 1, which is 1. 1 squared is 1, times a is a, and then I have a minus 1 on the outside, equals 0. To get a by itself, I'm going to add 1 to both sides, and my a is going to equal a positive 1. So I have everything I need to write my equation. So this would be f of x equaling my a, which is 1, times x, and then my k is a negative 1. So minus a negative 1 really means plus 1 squared minus 1. So this would be our equation in vertex form. Question 3. Write a quadratic function with points at -2, 0, 8, 0, and 0, 80. Now here they're giving us 2 of our zeros. So since I have 2 of the zeros, I'm going to write this in factored form. In factored form is f of x equaling a times parentheses x minus p times x minus q. So we're just finding our p, q, and then our a. So to do this, we have our zeros here. That means if I would have x equaling a -2, to put that as a binomial, I would have to make this equal to 0. So I would add 2 to both sides, and you would have x plus 2 equaling 0. So this is one of my binomials. And if I have an 8 here, that means I have x equaling a positive 8. To make that equal to 0, I'm going to subtract 8 on both sides, and we would have x minus 8 equaling 0. So I know that my equation is going to have an x plus 2 and an x minus 8. We need to find our a, our dilation, and that's where this third point is. This is our x and our y. So if I put 80 equaling a times my x coordinate is 0 plus 2 times 0 minus 8. And let's simplify that. So 0 plus 2 is 2. 0 minus 8 is -8. So 2 times -8 times a is a -16a equals 80. To get a by itself, I'm going to divide by -16. And if I grab my calculator, we'll do 80 divided by -16, and we get -5. So our a is going to be a -5. So we have everything we need for our equation. So that our equation would be f of x equaling -5 times parentheses x plus 2 times x minus 8. Question 4. Use the graph to state between which consecutive integers you can locate the roots. Again, the roots is another name for solution or x-intercept. So if I look at where it crosses the x-axis, that's here and that's here. So between which two integers, consecutive integers? So for this one, we would say between, and it's going to be between -2 and -1. And on this side, it would be between 4 and 5. Question 5. Solve square root of -10 times the square root of -15. Now to break this apart, I would have this as I, because remember the square root of -1 is I, and then I would have the square root of 2 times the square root of 5. So I'm just breaking down the radicals. This next one, I would have I, because I have the negative square root inside here, and then the square root of 5 times the square root of 3. Now an I times an I is a negative 1 times the square root of 5 times the square root of 5 is 5. And all I have left is the square root of 2 times the square root of 3, which makes that a square root of 6. So my final answer would be negative 5 square root of 6. Question 6. Use the formula V equals CI. Determine the voltage V of a circuit with a current C of 2 plus 5J and impedance I of 3 minus 4J. So we need to find the V when our C is 2 plus 5J and our impedance is 3 minus 4J. Now to solve this one, we're going to FOIL it. So we have 2 times 3, which is 6. 2 times negative 4J is negative 8J. 5J times 3 is a positive 15J. And 5J times negative 4J is a negative 20J squared. Now for here, we're going to treat the J like our I, or our imaginary unit. So if I combine like terms, I have 6 plus negative 8 plus 15 will give us 7J. And then we have minus 20, but J squared would give us a negative 1. So really I have this as a plus 20. So my final answer would be 6 plus 20, which is 26, plus 7J. And that would be our answer. And our label for that one would be volts. Question 7. Here we're going to solve 3x squared plus 5x plus 15 equals 17 by factoring. So to do that, we're going to make it equal to 0. So I'm going to subtract 17 on both sides. And this is going to give us 3x squared plus 5x minus 2 equals 0. Now because I have a leading coefficient bigger than 1, I'm going to use the AC method, which means I'm going to take my A and take my C and multiply them, and I get negative 6x squared, and that's going to be my new C. So now I got to think, what do I multiply to get negative 6x squared, but add them together gives me a positive 5x. That would be a positive 6x and a negative 1x. Now if I bring down the sides, so minus 2, I have one binomial on this side. Bring down the 3x squared over here. I have another binomial on this side. Now that I have two binomials, treat this like you're factoring by grouping. So I factor each binomial, so I can take a 3x out here, and that leaves me with x plus 2. And on this side I can take out a negative 1, and that leaves me with x plus 2. So our two binomials, I have a 3x minus 1, and I have an x plus 2. All I need to do is make each of them equal to 0 and solve for x. So here I'm going to subtract 2. One of my solutions is x equaling a negative 2. And on this side I'm going to add 1 to both sides. And then divide by 3. And my answer would be x equaling 1/3. So these would be my two solutions for that quadratic. Question 8. Solve x squared plus 4 equals 0 by factoring. Now for this one, do you have to factor? No, you don't have to factor it. In fact, I actually probably wouldn't factor this one. I would actually use the square root property. So I would subtract 4 on both sides. And I would have x squared equaling a negative 4. And to undo a square, you'd find the square root, and that would give us an answer of x equaling, the square root of 4 is 2, and then I have a square root of a negative 1, that would give us I. But remember, you have two roots, so that would be a positive and a negative 2i. Now let's just say you were going to do this by factoring. You can easily create this as, or write this as a difference of two squares, which would be x squared minus, and then in parentheses I would have a negative 4. And the reason why I would put a minus a negative 4 is that's because when I subtract a negative, I really have a positive. Now I have a difference of two squares, which would have to fit the format of a plus b times a minus b. So I would find the square root of the first term. So the square root of x squared would be x. And I have a minus. The square root of negative 4 would be a 2i. And then the other binomial would be x plus 2i. And if you made both of them equal to 0, here you would add 2i to both sides. And here you would subtract 2i on both sides. And that's how you get x equaling a positive and negative 2i. Question 9. A lawn in a city park is 45 feet long and 25 feet wide. The path with a width of feet will be placed around the park. And this should say width of x feet, because we don't know how wide it is. The city has enough paving material to cover a path with an area of 800 square feet. How wide should the path be to use all the paving material? So the first thing we need to do is create a quadratic. And we can do that by using the dimensions here. We want to find the dimensions of this whole side. So we know it's 45 on the inside and an x on this side and an x on here. So we're going to have 2x plus 45 as our length, and our width we have 25 and then an x here and an x here. So that would be 2x plus 25. And this has to make an area of 800. Now with this, since this 800, this is actually the area of the path that they have. So I have to add something to my equation. So let me get rid of this equaling 800. So we want to just find what the area would be for just the path out here. So we would have to subtract the area of this inside part of the park. So the area of that would be 25 times 45. So if we grab our calculator again, and if we did 25 times 45, we would get 1125. So we would want to subtract 1125 from this. So the area of the big rectangle minus the area of the small rectangle should give us 800. So we need to FOIL this. So we do 2x times 2x, which is 4x squared. And then we have 2x times 25, which is 50x. And then 45 times 2x is 90x. So 50x plus 90x. So 50 and 40 would give you, or 50 and 90 would give you 140x. And then we have 45 times 25, which is a positive 1,125. And then we have this minus 1125 equaling 800. Now if we simplify this, these cancel each other off. We want to subtract 800 on both sides to make it equal to 0, and we have 4x squared plus 140x minus 800 equals 0. Now we can factor out a 4, and when we factor out a 4, we get x squared, and then 140 divided by 4, so we'll grab our calculator again. So 140 divided by 4 gives us 35. So that'll give us plus 35 minus 800 divided by 4 gives us 200. Now this 4 doesn't mean anything anymore because we're just solving for x. So if we take what we have as our trinomial here, I have to think, what are two numbers I can multiply to get to negative 200, but add them together gives me 35. That would be a positive 40 and a minus 5. Make each binomial equal to 0. And since x has to be a positive number, I'm only going to do the second one because that's going to give me the only one that's going to give me a positive x value. And x is going to give you 5. On the other side, that would just give you x equaling a negative 40, which would not make sense. So the path should be 5 feet wide. Question 10. Solve by completing the square and then write the trinomial as a perfect square trinomial. So to complete the square, I take my b, which is 5, divide it in half, and square it. That, as a fraction, would give you 25/4, or if you were to put it as a decimal, that would be 6.25. So as a perfect square trinomial, you could have x squared plus 5x plus 6.25, or you could do as fractions, so x squared plus 5x plus 25/4. Question 11, we're going to use the quadratic formula to solve. Again, this is our a, this is our b, this is our c. So if you use our formula, x equaling negative b plus or minus square root of b squared minus 4ac divided by 2a. I would now have negative b, so a negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times our a, which is negative 4, times our c, which is negative 12. Divide that all by 2 times negative 4. Now we'll use our calculator for this. So the first thing I'm going to do is put my parentheses in for the numerator. So I have negative 2 plus the square root of 2 squared. So I'm just going to put 4, because 2 squared is 4, minus 4 times negative 4 times negative 12, end parentheses, because that's the end of my quadratic, or the square roots, and then the end parentheses again to end my numerator, because I got to divide the whole numerator by 2 times 4, negative 4, so I'm going to put in parentheses 2 times a negative 4. End parentheses, and that will give us an answer. It says no real answer, and the reason why you have no real answer is because the radicand is going to be a negative number. Therefore, I can't have a solution, a real solution here. So I'm going to have to write this, simplify this out, because I'm going to have a complex answer. So right now I have a negative 2 plus or minus the square root of, so we have 4, and then we have 4 minus 4 times 4, negative 4 is negative 16, negative 16 times negative 12. So if we grab our calculator, we got negative 12 times 16 gives us a negative 192. So I have 4 minus 192, which will give us a negative 188. And this is all divided by a negative 8. So I can break apart this square root of negative 188 as I, because I have the negative, and then I can break it apart as a square root of 4. And then if I did 188 divided by 4, we'll grab our calculator for that one. So 188 divided by 4. Now I'm just using a perfect square that I know works in there. I get 47. So that would be a square root of 47. And 47 is a prime number. I can't break that down. So right now I would have negative 2 plus or minus the square root of 4, which is 2. And then I have my I, square root of 47. And I'm going to divide each part by negative 8. So when I do that, my final answer, x is going to equal 1/4, because negative 2 divided by 8 is 1/4, plus or minus 2 divided by 8, that's going to be 1/4 I square root of 47. Question 12, find the value of the discriminant for this quadratic. Again, the discriminant is b squared minus 4ac. So my b is 3, so I got 3 squared minus 4 times our a, which is negative 4, times our c, which is negative 15. So that gives us 9 minus, and we'll grab our calculator again. We have 4 times negative 4 times negative 15. That gives us 240. So we have 9 minus 240, which will give us a negative 231. Since the discriminant is negative, I have complex solutions, so I have 2 complex solutions. If it was a positive answer, I would have 2 real solutions, and it would be rational if it's a perfect square and irrational if it was not a perfect square. And if it was equal to 0, it would be 1 real rational solution. Question 13, we need to graph this quadratic here. So to do this, we're going to find our axis of symmetry. So we take our opposite of our b, so with negative 6 divided by 2a, which will give us a negative 3. So I put my axis of symmetry through here. If we put a negative 3 in for x, this is 9 minus 18 plus 4. 9 minus 18 is negative 9, plus 4 is negative 5. So we have a point at negative 3, negative 5, so I'm going to put that point here. Then I'm going to use the axis of, or the c, because that's my y-intercept. So I'm going to put a point at 4. That would be here. Since I went 3 steps to the right of the axis, I can go 3 steps to the left. I have my 3 points. It has the equal to symbol, so that means I know it's going to be a solid line. And now all I need to do is determine where I shade. And the shading is going to be, since the y has to be less than the line means it's going to be everything below or on the outside of our quadratic, our line. And our last questions. solve this system of equations. So you can either use substitution, elimination. You could possibly also graph it as well. I'm going to use elimination. And to do that, I'm going to multiply this bottom one by a -1. So right now I have x squared plus 0x. I don't have any x terms, plain x terms, plus y. And then I'm going to bring this 20 over, so that's going to be a -20 equaling 0. On this one, I don't have any x squares in it, but a -1 times a -3x is going to be a positive 3x. And a -1 times a y is going to be a -1y. I'm going to bring this 2 over, so this is really a -2. And -2 times a -1 gives us a +2. And make that equal to 0. When I combine like terms, I have 1x squared plus 3x minus 18 equals 0, which means I can factor this. And I know it's going to be a +6 and a -3 because -3 times 6 is -18, and 6 minus 3 gives us 3. Make each of them equal to 0. Subtract 6, add 3. Right now I have x equaling a -6 and x equaling a +3. Now to find the y coordinates, I'm going to use this bottom one here. So if I have -3 times, if I put a -6 in here, that gives me 18. 18 plus y has to give me 2. I'm going to subtract 18 on both sides, and I would have a y coordinate of -16. And if I take that same one, -3, but put 3 in here, -3 times 3 is 9, plus y gives you 2. I would add 9 to both sides, and y would have to equal a +11. So those would be my 2 points for where those two functions meet up. And our last one, a video game developer determines that the profit in thousands of dollars from a new video game can be modeled by the function p of x equaling -2x squared plus 120x minus 1,000 when x is the price of each game. The game will be profitable if p of x is greater than 0. So we need to find out what would the price be of each game so that they can make a profit. The quickest way of doing this is use our graphing calculator. So we're going to go to your y equals, and we're going to type in -2x squared plus 120 x, and then minus 1,000. Now we needed to change our Windows settings. So if you hit the Windows button, I want to make sure that I can see above the x-axis, because anything above the x-axis is going to give us the profit. So I'm going to have a little bit below so I can see where it's at. So right now I'm just choosing x minimum at -10, the x maximum at 100. I don't know exactly how wide I should make it, so I'm just making a conservative number for my x maximum, so I'm just going to use 100. I'm going to count by tens. My y minimum, I'm just going to make that a -1,000. My y maximum, I'm making that 1,000. The x scale, the y scale, I'm just counting by 100. Now if I hit graph, we can see our parabola there. We want to find out where from this point to this point. So we want to know what are the exact zeros on it. Now there are a couple ways you can do this. You can use the 0 function to find them, or you could go to second graph, which is our table, and we just want to find out when y is 0, what is our x. So right now we have a really small y value here at negative 1,000. So if I scroll down, my numbers are getting bigger. Here's our first one, 10. So when x is $10, when the games are $10, it has to be at least $10 to make a profit. And to find our other 0, if we scroll down even more, numbers are getting bigger on the y side. And now it's starting to go down, and we want to go back down till we get to 0 and 50. So they will make a profit when it's at least $10 and no more than $50, because the graph, so if I go back to my table or my graph here, anything between 10 and 50, it's above the x-axis, which means it's above 0. That means they will make a profit. So those are the types of questions you can expect to have to be able to solve on the Module 3 test.